morning everybody. As Adam's said, my name's Christian Spring. I work here at the STRI as a researcher. I'd like to introduce my co-presenters today. We have Terlouw from Melspring. It's micronutrients and turf health, and how micronutrients can be used to help improve turf health and the benefits we're looking for in terms of, particularly in terms of disease resistance. If you have a little walk on this lovely area we have here, there'll be no surprise, it's a little bit thatchy. There's a reason for that. It's because, as you can look down your feet, you'll probably see the microdochium. It's the perfect haven for microdochium and other turf pathogens. We're looking at a combination of fertiliser programme and tank mix programme, and different combinations of the two. The fertilisers have slightly different forms of nitrogen, and the tank mixes have different combinations of stress relieving products, biostimulants and micronutrient trace element type products, and looking to see which of these combinations are giving the best turf quality, and do they have any impact in particular in this trial on disease. So again, if you keep following me, walking up this way, I've marked out some plots where we can see some differences. Now this trial is only been running since the summer, so it's going to run through this disease pressure period, through the sort of microdochium fuzz season. And what we've got here is we've got 4 plots. I've highlighted 4 plots. This plot just here, the one with all the lovely red thread in, is obviously our control plot. So this isn't receiving any nitrogen at all. It's not receiving any stress relieving tank mixes. So as a result, we've got quite a pale colour. It does look weaker turf than the rest, and you've obviously got a lot of red thread as a response to that. We also have, in this plot just here, a conventional fertiliser programme with the tank mixes, the stress relieving micronutrient tank mixes, and we can see there's quite a bit of microdochium patch within this particular plot. We contrast that with another particular treatment, and this one has sort of Melspring products in, which are a different type of fertiliser and trace elements, and we can see quite a bit of difference in the that you have to fit together to get the whole solution. But it's really interesting that you can see at this early stage in disease pressure season differences between the treatments. And I'll hand over now to Ton and to Joe, because they'll talk a little bit about some of the elements and the micronutrients which are involved in this kind of effect that we're seeing. So Ton, if I could hand over to you.
I would like to bring you back to the boards there, over there, and like to show you a little bit what we're doing.
So if everyone could just gather around the A-frames, because I think Ton wants to present the information in these posters.
Now, if we talk about stress factors in turf, there are biotic and abiotic stress factors. Especially when we talk about the chemical stress factors or the physical stress factors, drought, salt stress, nutrient balance, metal toxicity, there they give a reaction to the plant. The same applies for a pest or a disease. They will give you a stress factor. That stress factor gives a stress signal. Whatever you get stress signals, and stress signals automatically turn the plant into a defense. That is called the systemic acquired resistance. The plant will orchestrate its own defense and will allow a recovery of the plant wherever possible. Now, if you wait until the plant starts to defend itself, sometimes you're already pretty late. So there are ways and means to influence that. And you could influence it by inducing systemic resistance. There are nowadays possibilities to induce the resistance of a plant to stress factors. In our biopass, we have a type of sugar that will give the signal, which is almost identical to the signal given by the plant itself to defend itself. Once you start defending the plant, you need to amplify to make the signal bigger, because the signal starts at the cell, and from every cell to the next cell you need to transport the signal. The signal transport is done by polyvalent molecules, and silicon is one of the very important elements which allows you to transport signals to the neighboring cells. So if you're able to transport the signals, you're also able to transport the defense mechanism. And once you have arranged that the defense mechanism is spread throughout, you need to respond. And when the plant responds to disease, it will start to strengthen itself. And they do that with lignification. Lignification means you get more dense cell structures. So the cell walls become harder. And when the cell walls become harder, they are more difficult to penetrate by fungal mycelium or whatever. So what we have brought together is a package of products. First, we induce the signal prior to the plant getting sick. That means that the plant already starts to orchestrate its own defense. Then we amplify the signal, and later on we provide you with the nutrients that gear the defense mechanism. And if you want to see how the cells react when they have been wounded, and every time you cut your grass, you wound your grass. And so in order to get like we have on our skin, if you want to heal it, you need additional measures. And with this package we arrange that you are defending yourself. And you see here in the process we've done that copper has proven to give you a kind of...
Asked to have a look at the data, because that's a really powerful tool. Because if you've got the data to show, yes, there is a difference between here and here, and this product, this or combination of products really works, then that's a major improvement. And that's something that gives you confidence then that it's got to do what it says on the tin, and that you can use it within your program to get the best benefit, best effect. So I think research is really important, and that's why companies like Sheriff and Maelstrom and the companies represented here are spending money and resource into actually doing the research, because it provides the answers and the evidence, and it helps with the whole R&D process of where do we have to go now. Research isn't a static process. It's not, right, we've got a question, we've answered that question, great. It's, crikey, now we've got another 4 questions from that one answer. So we've got to go further down that progression to get more answers and further refinements, and that's how we improve, and that's how products, techniques, the whole industry as a whole is improving.
I would like to add something to that, if I may.
Go ahead, Tom.
Christian. Before you go to STRI, you first do literature studies, and you think about how you want to improve the turf. So what you do, you're going into literature. Then you find niche things. You're going to do trials on very small scale in pots. And when those trials in pots give you such results, this is control without disease suppression. This is slight disease suppression of 2 individual products. And then you go to the combination of 2 products, and you come to a control of approximately 94%. So if you add that stuff, and if you also add another product which also gives you control, then you are making a package that altogether brings you to a very stable type of turf, which performs like that, I would say, almost throughout the year, and only when the problems get worse, then you apply a fungicide. Now, before doing all this, I would like to show you a small picture, because I can talk a lot about a product, but if you look at this is a cell without lignification. This is a cell with lignification. Lignification means it gets thicker walls. Now if you are able, wounding like that or wounding like that, you get lignification through copper. So whenever a plant is hurt, it starts to defend itself by making lignified cells. And lignified cells mean that the density of the cell structure becomes much thicker. So it will be much harder to get through. And that is what we try to achieve with this combination of products. Now I hope that this allows you to, next time when we are getting into the market with these products, because they are not yet on the market. We are still waiting the results of the trials here and trials in Holland for the application rate. But I can assure you, if we have results like that, I'm pretty positive that we will get into the market by early next year.